Today we shall see about confusion matrix. Now after preparing the model, machine learning model or deep learning model, how we will test that the model is functioning correctly. So there will be some predictions and there will be some actual ground truth. Suppose let's say there is a binary classification with classification labels as 0 or 1. So there will be in the actuals ground truth 0 and 1 and the predicted ones will be 0 and 1. Suppose there are some cases that are predicted as 0 and in the actuals also they are 0. So they will be called true negative. Similarly, they are predicted as 0 but in the actual it is 1. In the ground truth it's 1. Then it is called a false negative. Similarly, if it is predicted as 1 but the actual was 0, then it is false positive, and if both predicted and actual are 1, then it is true positive. How the naming convention is done is like first part is true or false, that says whether the predicted and actuals have matched, whether they have been correctly predicted or not. So when it is correctly predicted, it is true. When incorrectly predicted or the actual and predicted values are not matching, the labels are not matching, then it is false. So first part is out of the true positive, true negative, the true part is whether it is matching or not, and the second part positive or negative. Now if whatever we have predicted, we write that part. Now if we have predicted as negative, it's negative. If we have predicted positive, then it's positive. So ultimately from a naming convention only you can get to know whether the actuals and predicted have matched or not. Generally in the confusion matrix you can keep the actuals in the rows, predicted values in the columns as well, but let's maintain a convention to write predicted values in the rows and actuals in the columns. Now this was for a binary classification where there were two labels. Now if we have multiple labels like 0, 1, 2 or random labels like apples, oranges, bananas, so what we can do is we will have n cross n matrix. Now where n is the number of labels. Now we have number of labels. Similarly we'll put actuals and we'll put predicted, actuals in the column, predicted in the rows, and the diagonals will be the ones where we are representing the true or the matching values. We cannot say as anything positive or negative, but this is how the confusion matrix will grow if the number of labels are increased. And since we have multiple columns or multiple labels, what we generally do, will combine into one versus rest method, where 0 will stay and this whole will become other. We'll keep one and combine the rest of them to be another label.